Hello, everyone. I want to welcome you all back to the channel. It's been a few days since I haven't uploaded anything. If you are new to the channel, let me first allow me to introduce myself. My name is Alfred Cromwell. I am the founder of City Tutoring, and this is not only it's mainly a math channel, but I also like to discuss current affairs. And on Sundays, I give a moral message, time permitting. So if you are new, you will see a mix on the channel of contemporary topics, of the moral questions, but also mathematics, pure mathematics. We are a pure mathematics channel. And also so is city tutoring. By the way, we still hold to the classical 19th century and before model of what college and university education should be. So I want to welcome you all back, those because everybody who likes this channel, you are all seekers of truth, in particular mathematical truth. And here the symbols shed their superficial cloak and reveal their eternal form. And if you survived part one of this video, and we defined the proper definition of vectors, which they no longer teach in the majority of schools, and we learned that vectors are not mere arrows, but really majestic denizens of abstract spaces, we're going to plunge deeper into the very essence, or at least the one of the introductory components of linear algebra, which involve linear combinations and the crucial distinction between dependence, linear dependence, and linear independence. So make no mistake, this is not the fluff your average so-called advanced placement AP calculus class deigns to offer. Uh, Really, those glorified remedial courses that are obsessed with mechanical procedures and standardized tests, we never touch. They never touch these elegant fundamentals, and we do. So we are very not in the business of being compared to them. They prefer students to shuffle symbols mindlessly, blissfully unaware that they are missing the very backbone of modern mathematics. You know, a lot of these students today, the so-called straight A students, they're not. I'm not impressed by them. The majority. So we're not going to indulge in educational half measures or corporate textbook concessions. This is pure mathematics. It is rigorous, it is unyielding, and it is an intellectual rite of passage for those of you who are hungry to understand and not merely compute. We can let the engineers do the computing and the computers and all that nonsense. If that calls to you, steel yourself because we're going to get deeper into the definitions today. Uh, in terms of how will the lesson unfold, we're not really interested either, at least I'm not, in the frenetic pace of modern so-called education. It's not really education at all, but um, where students are rushed through material as if in a factory assembly line. So here we're going to follow a more gentlemanly rhythm. You've noticed that this month I've slowed down on some of the posts because it's really August, and I'm really I'm taking it easy in August. I mean, you should always be taking it easy, but especially in the deep summer months when it's so hot. So this is going to be part two of a carefully measured series because you do not have true mastery without if you hurry. True mastery cannot be hurried. Gentlemen do not labor past, I don't know when this video will be uploaded. That's something my assistant does, and I have no idea what he does about that. He's a tech person, so I have no idea. But it's 12:45 p.m., and I'm about to go to lunch very soon. So I don't labor past 2 p.m. ever, because by then the mind's appetite turns to finer things. Maybe I'm already thinking at 2 p.m. I'm already thinking of a nice leisurely dinner, thoughtful reflections, and perhaps not these days, but back in the day when I was younger, a pipe or two. These days, however, my lungs I think are grateful for the fact that there's no more smoke in them. But it's a practice that is sorely lacking in today's American whirlwind of cramming and burnout. but we have to cultivate not just knowledge, but wisdom. So I want you all to take your time and I want you to savor the elegance of true, pure mathematics as we proceed one step at a time. Um, but this is something that it has been bothering me for a very long time, that this rush sort of approach to education, this cramming, this sort of everyone talks now in a rush. So I really cannot help but pity those poor souls who live only to work. They are shackled to endless toil as if existence were a factory shift rather than an art to be savored. And those lives, they are really being dictated to by the tyranny of corporations. And that kind of spirit is foreign to the cultivated spirit of a true mathematician who knows that brilliance and true understanding, it flourishes not when you're exhausted, not in exhaustion, but in leisure. And we have to cultivate a different approach to life. So I want you to take your time and just savor the definitions. Just take it easy, relax. I'm always very happy when people tell me that. I've gotten this a lot, but people always say to me that when they speak to me, they feel unusually relaxed. And I said, that's because I don't live to work. I don't answer to the clock. Well, I answer to my clock, but I don't answer to a corporation. So anyway, here goes some of the definitions that we left out in part one. All right, so here is the first thing, linear combinations of vectors. But before we address that, I want to address an issue that came up that was really shocking to me. I had no idea that this was even a debate. I had no idea this was a discussion. But apparently, after an email I received 2 weeks ago, I think it was, and comments here and there, I had no idea, really, that my use of Comic Sans as a font was actually an issue. And apparently, it was enough of an issue for a young man to email me. Apparently, he took himself so seriously that he did, criticizing my use of Comic Sans. So let me give you a little bit of background and then a response to that. One of the reasons I use Comic Sans was because since I use a black, I've always used a blackboard, but since I can't obviously do it on Microsoft Word, from visually for me, the closest thing to chalk, if I were writing in chalk, was Comic Sans. There was really no other mystery behind it, but it's really a tiresome charge that you cannot possibly be serious, apparently, if you dare to present mathematics in Comic Sans. And to those of you who are such critics, I say this: if your grasp of rigor is so feeble that it can be toppled by a typeface, then perhaps you never were rigorous at all. Euclid could have written the elements on parchment in crayon, and it would still have more mathematical weight than an entire semester of your so-called serious LaTeX or PowerPoint slides. It's ridiculous. A true mathematician understands that beauty lies in the argument, not in the font. That elegance is in the proof, not in the typography. So Comic Sans, I don't know, there's so many of them. Whether you use Comic Sans or, I don't know, Arial, or whether you carve it into the side of a turnip, it makes no difference to the truth of a well-structured theorem. The fact that some of you are more troubled by my choice of font. I even had a girl last week who said that. She said, he must be a troll. He's using comics. I can understand that from a female. I really can. But from males, I mean, what kind of people are you? There's no manhood anymore in society. So if font offends you, that says a lot about you. You're ridiculous. You're weak. You're pathetic. And maybe you don't belong on this channel. But it makes no difference. Whatever font I use, and I use whatever the hell I want, to the truth of the well-structured theorem. The fact that you are more troubled by my choice of font than by your own shaky grasp of linear independence and mathematics in general says more about you than it does about me. And besides, Comic Sans, apparently, I've learned, maybe it is the perfect font for exposing because it has exposed the humorless, the pedantic, and the tragically self-important. Some of you take yourselves way too seriously for who you are. Look at yourselves in the mirror. Don't take yourself so seriously. You've done nothing in life. It's like a litmus test for people who take themselves. You've taken yourself so seriously that you forgot how to think. So I don't care if my choice of font, if you don't like it, you can always go to other channels. There are many other fake channels. There are so many fake channels out there that you can watch that don't even do mathematics. They do special effects. If that's what you're looking for, you're in the wrong place, sir or madam. I'm not here to entertain you. I'm not here to do as you tell me. I'm here to share the truths of mathematics. I was nice today. I was generous because apparently it became so much of an issue for some people. So I created a little font here that perhaps it won't hurt your little eyes as much. So I did a little, I actually had to create this in this way. But if I ever feel like using Comic Sans and that bothers you, then you should leave the channel. I don't need you. I'm old enough. I mean, come on. I'm old enough at this point to have survived many decades. Maybe not. I'm not a centenary. I'm not 100 years old, obviously, but I'm older than many of you. And I'm here. I am, and I think I've done a pretty good job in life, at least personally. Maybe not for others, but at least for what it matters, for myself and for God. So I don't need your validation. I don't need you to tell me what font I need to use. If that's how you go on through life, that I'm sorry for you. I feel very bad for you because you must be a very miserable person. But anyway, going back to more serious things, these are linear combinations of vectors. So these are called, the example you see here is called a linear combination of the vectors. So if you want to find the linear combination of four tuples, let's say, you have this as an example here. So the quadruple, -4, 9, 34, and 18, is what we say is a linear combination. It's a linear combination of -2, 5, 8, 4, 1, 7, 3, -1, and 0, 5, -1, -2. By the way, for the person who emailed me, I believe my assistant sent you an email about the font issue. We're not going to waste our time emailing you. It's a waste of time. If anything, you should be paying us for our time. So this is the response that you. This is the response. So if you were the person and you know who you are, if you were the one who emailed me 2 weeks ago, a week ago, I can't even remember. This is the response to your complaint. All right, next part. All right, there's something called linear dependence and independence. So a set of vectors is called linearly dependent if at least one vector can be written as a linear combination of the others. Conversely, you could say that the set is linearly independent if none of the vectors can be expressed as a linear combination of the others. And we talked about what the converse means. Any serious mathematics class should teach you those things. But if you don't know what it is, there's a logic playlist on this channel. For example, you have four quadruples here, right? And those are linearly dependent because, as we saw above, the first is a linear combination of the other three. And you notice that the quadruple, the four zeros there, is a linear combination of any set of quadruples, since whenever you multiply each vector by zero and adding, you yield the zero vector. So in other words, the zero vector is the universal parasite. I always call them like that, of linear combinations. On the other hand, you have these quadruples. Those are, these last four here, those are linearly independent. And why is that? Because none of these can be formed by combining the others. So you have 1 and then triple zero. Notice that you have a 1 in the first coordinate. So the others have zeros there. So no combination of the latter can produce it. And the same reasoning applies to the rest. So you have similarly vectors like 100a or 010b or 001c. And those are independent as well, regardless of uh, what A, B, and C are. So now we're going to look at a fundamental property as well. Now, this is the most effective test for independence. So, outside of the obvious cases where you have dependence or independence, where you're really staring at you in the face, this is the most effective method. It's this property here. I don't know if some of you have learned it. If you haven't, it's a really important property. So, these vectors, u sub 1, u sub 2, u sub 3, etc., they are linearly independent if and only if this equality holds. And it only holds when all of x sub 1, x sub 2, x sub 3, etc., is equal to 0. So, in other words, if the vectors are linearly dependent, then there exist scalars that we have here, not all 0, that satisfy the above equation. And if the vectors are linearly independent, the only linear combination of them that yields the 0 vector is what we call the trivial one, where all scalars are 0. So here is one way when you can apply the fundamental property in order to test the linear independence. We have a rather elegant little set of set here. Our aim really is to establish with full rigor that these vectors you see here, we have 100a, 010b, 001c. We're going to see they are indeed linearly independent. And so we have to proceed with calm precision here. We will introduce here in the proof unknown scalars. We could use the Greek letters alpha, beta, and gamma, and they form their linear combination here. So the question before you is really simple. Must alpha, beta, and gamma, must they all vanish in order for this equation to hold? Or could some non-zero, perhaps a sly non-zero intruder, escape our logical net? So if you expand component-wise, you get these combinations here. Whence alpha, beta, gamma, when you combine them here, you get 0, 0, 0, 0. And at once, the first 3 coordinates yield. You get alpha equals 0, you get beta equals 0, and you get gamma equals 0. And so without appeal to hand-waving, you don't really need the crutches of numerical guesswork here. You can conclude with certainty that these 3 quadruples are linearly independent. So hopefully this was helpful as a part 2. Next week, probably, time permitting, we'll talk about the rank of a matrix. And it's a standard linear algebra term. So it's a notion that it's at the same time it's elegant, but it's also merciless, for it tells you exactly how much substance a matrix truly possesses. So anyway, if this video was helpful to you, as you can see, please subscribe. Please continue to support the mission of this channel, which is to share pure mathematics, no fluff, no special effects. Everything is real here. Everything is the old school, the pure mathematics way. And I think some of you really appreciate that. And for those of you who have sent in donations to City Tutoring recently, I praise God. Thank you so much for that. I don't know what to say. I wish I could be more of service to you all. And if I can help you in some way that is real and genuine, feel free to write me a letter. I've been writing letters all week. That's one of the reasons why I've been delaying posting videos, because I actually get handwritten letters, which is amazing. People say that no one writes letters anymore. That's not true at all. There are a lot of young men who write me letters, and they look for advice, and they look for they really have a different attitude of mind. And I get letters all the way from Texas. I get letters from France, Spain, Italy, Australia, United Kingdom. I recently received a letter from a gentleman in Spain, another gentleman from London, who is really, he's fed up with the immigration invasion that they're suffering. A lot of Europeans, but so are we in the U.S. So anyway, I don't make apologies for this because these are the facts. And like I said, if facts offend you, then you might not be you're definitely in the wrong place. Thank you all, and hopefully you have a good week. I'll try to upload another video, maybe tomorrow, Saturday, on we've been talking about the theory of groups as well. And I don't know yet the plan for Sunday. I might, if I'm around, we'll do a Sunday message. But if not, then we'll postpone it to the next week. Stay cool, everyone, in this hot weather, and hopefully everything will fall into place. Thank you all.